Ever feel like your IT resources are either bursting at the seams or sitting idle and costing a fortune? Well, welcome to the world of capacity management. My name is Kelsey Lemon, product marketing engineer for the VCF division here at Broadcom, and I'm going to be your guide in this three-part series where we're going to align VMware Cloud Foundation's capacity management capabilities with some practical use case scenarios. So this series is really intended to equip everyone here with both conceptual knowledge and practical skills to manage capacity in VMware Cloud Foundation. So at the end of this three-part series, you're going to be able to leverage AI-driven analytics and capacity management. You're going to be able to explain how VCF's capacity engine uses predictive analytics, periodicity awareness, and exponential decay to improve projections. You're going to be able to understand how these insights feed into optimization, cost analysis, and migration planning. You're going to be able to perform practical tasks in capacity management. Say, for example, assessing capacity, being able to leverage the capacity dashboards and the projections and all the different optimization recommendations. Again, on that topic of optimization, they'll be able to use reclamation and the right sizing features inside of VCF to reduce waste and improve efficiency. You're going to be able to plan better, right, in terms of just running workload scenarios to anticipate costs, risks, and identify your resource requirements. And then last but not least, right, you're going to be able to make informed business decisions, being able to correlate technical capacity insights with cost savings, performance improvements, and even budgetary planning. And in the bigger scheme of things, to be able to support long-term business strategies, right, by really ensuring IT scalability and reliability. And so with that, let's just go ahead and jump right in. And so let's just level set by defining what capacity management is. Capacity management in IT just really ensures that an organization's resources, right, whether it's the servers, the storage networks, cloud services, what have you, they're all right sized to meet current and future business needs. It's about balancing cost with performance, having enough resources to handle demand without overspending. And some of the key elements around capacity management is really around monitoring usage, right? Tracking CPU, memory, and storage to really prevent downtime and bottlenecks. It's about forecasting demand, right? It's about predicting future growth based on trends, business initiatives, or even seasonal spikes. It's about optimizing your resources around the idea around right sizing workloads, is around fine tuning performance, and even reallocating resources to better control cost. And then last but not least, again, it's around that strategic planning aspect, right? And so in short, capacity management is like budgeting for IT resources, just really ensuring that the right balance occurs between cost, performance, and even future readiness. And as with anything that's important to manage, right, there's challenges that's going to come with it. And with capacity management, those challenges are really around data and analytics. Accurate and real-time performance data is essential, but quite frankly, sometimes it's hard to capture and to analyze. And then more times than not, the tools that are available to do it, they're siloed. So separate monitoring tools just really make it hard to correlate usage across IT. Then again, this whole notion around forecasting demand, workloads are dynamic and spikes are unpredictable. Underestimating demand can lead to under provisioning, causing performance issue, or over provisioning can even lead to wasted resources. Then again, this notion around capacity planning, right? Capacity management tools often sometimes, require significant customization and integration. So selecting the right tools and implementing them correctly and just really ensuring that they are integrated in such a way where they can actually provide actionable insights. It can be very complex, but it's really, really essential that it's done. And then last but not least, again, this whole notion around balancing cost and performance. Again, under provisioning hurts users. Over provisioning wastes money. So cost management is going to be something that we're going to be covering in a later series known as the FinOps series. So be on the lookout for that. And with that, let's just keep moving. So let's just talk about recent industry trends, right? That's one of the things that's actually making the challenges that we just talked about even more complex, right? And so according to a recent survey, businesses are actually looking at reducing Capex to address, economic issues. And this reprioritization of sorts actually makes capacity management more reactive. It's costlier, it's riskier. And as we work to do more with less to make sure that we get the most out of our existing infrastructure, we have to potentially deal with things like aging infrastructure, right? That presents a reliability issue in terms of maintenance and even some security issues. We're talking about resource shortages, right? Where systems could run out of capacity during spikes. And then last but not least, right, there's this pressure to optimize, right? Meaning more reliance on monitoring, automation, and even forecasting. But even with CapEx plans decelerating, right? Companies have seen in a way that there is basically a light at the end of the tunnel, right? VCF operations is uniquely qualified to help you address all the challenges that we just talked about because it can help you assess capacity utilization. There's a unified visibility across the environments. It provides AI-driven predictive analytics and then even provides projections as to when capacity will run out. You're able to leverage VCF to optimize capacity utilization, right? Right sizing workloads based on actual usage. You're able to reclaim idle resources, whether it's a powered off VM, some snapshots, orphan disks, what have you. And you're also able to automate optimization. And then when you get to that final stage, that final phase, you're able to plan for your future capacity needs, right? You're able to forecast capacity for new workloads. You're able to model infrastructure changes. You're able to analyze any cost implications. And you're able to do this with its what if planning scenario feature. We're going to be looking at that in a little bit more detail later. And so basically, here's another view of that previous slide, right? So one of the things that's really, really important to note out here is that, in the initial phase, in terms of where VCF can help you, you're simply just trying to assess your current capacity usage, right? And you can use the features here to answer questions like, do my data centers have enough capacity? How long before my resources run out? How many workloads can I deploy? You can answer all of those questions with these specific features and capabilities that you see underneath this assess column. And as you go into the optimization stage, you may have questions like, do I have redundant or oversized workloads? What resources can I reclaim? And where can I reduce costs without impacting performance? You're able to answer all those questions with the specific features and capabilities listed under the optimized column here. And then last but not least, right, as you plan for the future, you may need to answer questions like, how much capacity do I need for a new project? What's the impact of workload migration? What investments, if any, are needed and when are they needed? Again, as you look at the third column here under plan, these are the features and capabilities that can help you answer these questions. And so now, before we take a look at some practical use cases of VCF's capacity management capabilities, I think this is really a good time to talk about what's happening underneath the hood, so to speak. And so with that being said, you've heard me say this earlier, but VCF leverages an AI ML powered analytics component, right? The capacity engine. And what it does is that it actually analyzes historical data and actually predicts future workload utilization to provide these actionable insights into resource capacity, as we go again from these different columns, going from assessing to optimization to even planning for future capacity needs. And so when we break it down at a component level, we're looking at predictive analytics, right? And so instead of just showing past usage, the capacity engine actually takes your historical data and projects it into the future to estimate when you may run out of capacity. There's periodicity awareness, right? And so this is really around understanding patterns in your usage based on calendar, whether it's daily, weekly, or even monthly cycles, and it incorporates those time pieces into your prediction, so it's time aware. Then there's also this notion around exponential decay, right? And so basically the capacity engine gives more weight to recent usage data, allowing it to adapt quickly to changes in your environment. And then with all that being said, there's multiple uses for this feature, right? Because the engine's projections are used across many features within VCF, such again as workload optimization, right sizing, cost analysis, and even migration planning. So essentially, it helps you to proactively manage your IT infrastructure by predicting resource needs based on intelligent analysis of both past and current trends. And with that, let's just take a look at some practical examples of VCF operations in action, starting with assessing capacity. And so basically it all starts here on the assess capacity page. Here it's going to help you answer that initial question. Can I get an overview of how the infrastructure that I'm managing, how is it being used? And on this page, VCF operations help you assess capacity across your data centers. You're able to understand how much capacity is remaining in those data centers, and even understand how much time you have before capacity runs out. And you're even able to view opportunities for cost optimization. And so with that being said, and we're going to take a look at this in more detail in a minute, but in terms of the anatomy of the page, right, the capacity page consists of several panes, including the overview, which shows you your data center in order of time remaining, where the most constrained data centers appear, as well as provide insight into their current costs. You've got this time remaining widget, which specifies which clusters are most constrained, and it actually displays the criticality of the cluster. Then you also get optimization recommendations, which actually show the number of reclaimable VMs and the associated cost savings. And along those same lines, you're able to view reclaimable VMs, which allows you to navigate to the reclaim page to start that reclamation process. We're going to be covering that in more detail later as we talk about optimization. And then with that being said, you're also able to modify how the default projections are even calculated by just simply clicking on the capacity configuration details. And with this option, you're able to do a couple things. We're going to be showing this in a minute, but you're able to adjust, things like criticality and warning thresholds. You can set a time in days where VCF operations can provide a warning before the cluster reaches critical capacity levels. And this should really align with how much, or how long, I should say, that it takes you to acquire, new hardware. You're able to adjust the time remaining. You're able to modify your business or your operating hours, and you're also allowed to enable allocation models as well. We'll talk about that too. So to begin assessing your capacity, you just go to the capacity dropdown, and here we're going to get a view of all of our data centers that are color coded by criticality. Red data centers need more attention, and green ones are normal from a capacity point of view. We also see their optimization status as well as potential cost savings. And so let's just click on our most critical data center with 0 days remaining. And as you can see, the data center has 4 clusters, 3 are normal and 1 is critical. And as we see the capacity projection for each cluster on the lower left here, we get a really good sign of that periodicity that we're talking about, with it being time aware. And so now let's just go to a data center with a little bit more data, right? And so now we're starting to see some optimization recommendations here, right? And so for example, we could optimize our capacity by reclaiming resources such as deleting snapshots, some idle VMs, or some orphan disks. And now let's just look at the utilization chart. And here we can see a couple things. We've got that top line that shows the usable capacity. This line here is my historical demand, and it tracks how much of my resources are usable within the time that's being used. This vertical line right here, this is the present date, and the information to the right of all of this is my projected capacity. So let me just change my timeline so that we can see where my demand crosses over the usable capacity timeline. And this is actually the point where I'm going to run out of capacity right here. So in this case, I have 54 days to get in front of this issue before it becomes a real problem. So now let's just double click and get more details on this cluster. So let's just take a look at the capacity remaining widget. This is saying that I have a projected capacity remaining of 25% based on a projection that's looking 3 days into the future. VCF is also telling me that I can fit 91 additional VMs based on the average VM size and utilization rates in this cluster. I can also create different VM sizes like small, medium, and extra large, and VCF will do the capacity remaining calculations for me. And if I had a shortfall, VCF would also tell me how many VMs I have beyond my capacity as well. And finally, we can see a breakdown of how capacity is being reported across CPU, memory, and disk space demand. We can see total capacity in the cluster. We can see usable capacity minus HA and buffers. We can see used capacity, again, which is that 3-day projection for time remaining, as well as what we have reserved for HA and buffers. And for more detail on these capacity metrics, I can just simply click on how much capacity remaining is calculated so that I can get a full understanding of the definitions and all the terminologies and what's being leveraged here. The capacity engine also gives you the flexibility to customize its settings. And so to do that, all we have to do is just click on capacity configuration details. And here, we can set the time remaining criticality threshold, which controls warning levels for time remaining. We can set that based on our right sizing frequency. We're also able to change risk level configurations where we can choose between conservative, which is the default for production, or aggressive for non-critical workloads, and even peak focused modes. Now, if you recall the diagram for the capacity engine earlier, capacity uses the upper bound of the projection range for sizing, aggressive uses the lower bound, or the mean, I should say, of the upper and lower bounds, and then peak focus really accounts for sporadic peaks in both the workload and the demand. And you can also enable the allocation model as well. And the allocation model is optional. It basically works alongside the default demand model, and with it you can choose whether you want to overcommit your resources or not. Overcommitting helps you measure utilization of resources in a pay-as-you-go model, and when you do not overcommit, the utilization of your cluster would never exceed 100%. And if your resource utilization is over the allocation ratio that you set, capacity remaining becomes 0. And you can also factor in capacity buffers as well. And so this is a configurable percentage of total capacity reserve within a policy for resources like CPU, memory, and disk space that reduces the usable capacity available for workloads. It basically serves as a safety net for future growth or specific scenarios such as a stretched cluster requiring capacity in a remote site. And then finally, you can adjust business hours. So for example, you can define business hours as Monday through Friday from 5 a.m. to 5 p.m. to focus on capacity management during business times and to ignore after-hour activities like backups and scans. And so with that, this actually concludes part 1 of our capacity management series. And so with that, be sure to check out part 2, where we're going to focus on how to use VCF to optimize your capacity.